Okay, so as I was saying, we will see in today's lecture the components which are used in electronics laboratory. Okay, so what we will see in today's lecture. So for any component we will choose, we will take that component and we will see its symbol, its application, its type. Okay, then we will take its material, what are the uses, that kind of thing we will study or we will deliver in today's lecture. So this is the diagram which will tell you that what we are going to see today. Okay, so one by one we will take component and then we will see this all parameters for the components. So now next and very fundamental component, that is resistor. Okay, so your resistor symbol is like this. Okay, then what is the use of resistor? Many 11-12 students, they study resistor, but they don't know the use of the resistor. So it is used to limit the current in the circuit. Now what is this limit the current? Okay, let's say if you are using or you are making a very small simple circuit which is made up of let's say which is made up of LED and simple battery. So at that time, suppose you want to limit the current, then what you need to do is you need to use the resistor because it opposes the flow of the current. Okay, so it is used to limit the current in electronics. Okay, so which are the types of the resistor? So in market we will observe carbon resistor, metal film resistor, and wire wound resistor. But in electronics laboratory, mainly we will be using carbon resistors. Okay, so in 12th or 11th also you may have observed this kind of resistor on which you have the color code. How to find the value of a resistor? You are right now using the color codes to find. BB Roy goes to London, that kind of thing you are doing, no? So that are the carbon resistor which are made up of carbon. Okay, so carbon resistor is made up of carbon. Then metal film resistor. So there are a metal film which is connected or which is wound on you can say resistive material, that is metal film resistor. Then wire wound resistor, especially wire wound resistor, they are used for high power applications. Let's say wherever you are using 230 volt or more than that, at that time we are using that wire wound resistor. Okay, so these are the three basic types of resistor. Material will depend ke kaun sa resistor hai. Its resistance unit, we all know that it is in ohms. And how to measure? If it is carbon resistor, you can make it with the color code. But in laboratory, we use a device. I will show you what is DMM. It is called digital multimeter. Okay, so that device is used to measure the resistance. Okay, let's see the next, which is a different type of resistor. Now I have tried to make the presentation interesting by showing you the real figures of this component. Okay, so carbon resistor will be looking like this. You can observe the color codes onto that. Okay, these are the metal film resistor. So there are metal films on the resistive material, as you can see over here. Another which is wire wound resistor, which is used for the high power applications. Okay, metal film resistors, they are offering high resistance. Okay, so that is the main application. Over here, carbon resistor will be up to few mega ohms. Wire wound resistors mainly having the use, like it is used for the high power applications. See, normally whenever you go to the market to buy a resistor, what you will ask? You will ask for its value. Okay, and second thing, you need to ask it for the you can say you need to ask for its power rating. So power rating is also important. Okay, normally in laboratory you may have seen this kind of carbon resistor which are of 0.25 watt power or 0.5 watt power. Okay, but if you want to work with the more power, let's say if you need let's say you need 1 watt or 2 watt or 3 watt resistor, then what you need to do is you need to have this wire wound resistor or another resistor which are thick resistors which are bearing more power. They are called the power resistor. This kind of resistor also you may have observed in some TV circuits or wherever it is high power. Okay, so these are the you can say power resistors. Now, do you have any queries? So let me check the chat box once.
No.
Okay, fine, not audible. uh, I think everyone is able to hear, no? Someone is facing problem, they are required to uh, re-logging. I will log the meeting after few minutes now, okay, for security reason. Okay, another type of register which are which are observed, they are called the variable register, where you will have three terminals. See, normally these registers which you have seen earlier, these are of two terminal. This is three terminal. So this terminal and this terminal, first and last terminal, will have the highest value, and the middle terminal, that will have, you can say, that will have the you can say in, I mean, movable part. Okay, so there will be variable values available between this point and this point, as well as between this point and this point. Let me give you simple example. Let's say this total is of 10k register. Okay, so if you change this rotatory part, okay, and you change it, and if you get between this 1 and 2, let's say you are getting 4k, so between 2 and 3 it will be 6k, so total it will be 10k. So this variable register, where it will be used, let's say you don't know, or you don't have the exact you don't have exact things in your circuit. Okay, you don't know the exact resistance value. So at that time, what you can do is you can keep the variable register, you keep on changing the value of the resistor, and then you will be able to set the exact value of that resistance. Okay, so this is about the resistance. Next is inductance. Wait for a minute. If someone is having some problem, let me check it. Okay, fine. So let us move to the next, that is inductor. So inductor symbol is this. Okay. Now, what is the use of the inductor? It is, you can say, electrical or electronics component which is used to store the energy. And most importantly, till now you may not heard about that, that it is used to, or it is used as a temporary current source. Okay, it is used as a temporary current source. Okay, so now what is this temporary current source? Temporary current source, that means whenever you are operating, or you are, let's say you are storing the energy into the inductor. Okay, so whenever you want to utilize that energy, this inductor will behave as a temporary current source. There are two kinds of things as a source in electronics. One is called current source, one is called voltage source. Normally we are using in laboratory voltage source. Okay, so inductor will provide that energy in form of the current. So अब उसके पास जब तक एनर्जी होगी तब तक वो करंट प्रोवाइड करता रहेगा. दैट इज कॉल्ड टेम्पररी करंट सोर्स. इट इज नॉट परमानेंट, यू कैन से करंट सोर्स, बिकॉज उसके पास जितनी एनर्जी स्टोर्ड है, आप पहले उसको चार्ज करते हो, तो जितनी एनर्जी स्टोर्ड है उतना वो दे पाएगा. Okay, it will look like this. It is made up of simple copper wire bounded. Okay, very, I mean, experts in that field that can design an inductor of particular value of Henry, because it is difficult to design. So we need to take you can say training to design a inductor. Okay, now the property of the inductor. Okay, it behaves as a short circuit for the DC. We know that inductive reactance is equals to 2 pi FL. That formula you have studied in standard 11th or 12th. Okay, where 2 pi is constant, F is the frequency of operation, and L is the inductance value. Now if I take DC supply, DC supply is nothing but a constant voltage, so it has zero frequency. So if I keep zero value over here, okay, so XL will be zero. So zero reactance, that means it's short circuit for the DC. For high value of the AC, it offers high impedance. Let's say F is high, then you will have XL very high. So it is offering high impedance for the AC. Now this is very important property of the inductor, which is utilized in making the filter. What is filter? I will explain you whenever I will explain you the diode circuits. Filter is used to filter out the you can say AC content from the waveform. Okay, inductance is measured in Henry. Everyone knows that. Okay, so this is about inductor. Next component, which is like inductor, we are using in the laboratory, which is capacitor. Capacitor symbol is like this. Okay, it is also used to store the energy. Now what is the difference between capacitor and inductor? Whenever you charge the capacitor and afterwards whenever you take the energy from the inductor, it behaves as a temporary voltage source. Remember, inductor was used as a temporary current source. This will behave as a temporary voltage source. Now how it is made up? It is made up of two metal plates, and in between you have to use dielectric material. Dielectric material means you have an insulator in between. Okay, and capacitors are of various type. I will discuss that in the next slide. The unit of the capacitance, that is in farad. Okay, what is the property of the capacitor? जैसे हमने इंडक्टर की प्रॉपर्टी देखी, वैसे ही कैपेसिटर की प्रॉपर्टी क्या है? It will behave short circuit for the AC. How you can prove that? Let's say if I am using, or if the formula of the capacitive reactance is Xc is equals to 1 upon 2 pi Fc. Okay, now in this formula, if I have 2 pi constant C, that is in farad, if I keep high value of F, okay, then this denominator term is very high, so Xc will be near to 0. So you can say it will behave as a short circuit for high frequencies of the AC. And what will happen if I keep F is equals to 0? That is for DC. For DC, I have to keep F is equals to 0 over here. So Xc will be infinite. So it will be offering high impedance for the DC. High impedance, that means very high impedance means it is treated almost as open circuit. If you are having the resistance in hundreds of mega ohm, it will be treated as open circuit. If you have resistance 0, then it will be treated as short circuit. Okay, so for high frequency AC, it will behave as a short circuit. For DC, it will behave as a open circuit, in short you can say. Now we will go for the types of the capacitor. So type of the capacitor is first of all electrolyte capacitor. Okay, so this is electrolyte capacitor where you will have construction wise difference in every capacitor. So over here there will be one oxide layer and there will be one liquid which will be behaving as a negative terminal, and there will be positive terminal. Now remember, there is only one capacitor where the polarity matters. In electrolyte capacitor there is polarity, plus and minus. So whenever you are connecting it in the circuit, you have to check the polarity. The longer leg of that electrolyte capacitor is positive, shorter one is negative. The value of the capacitor will be written over here. It will be written on that case. That will be right now you can see over here, it is 22 microfarad. This is the highest value up to which you can charge the capacitor. Different values of the electrolyte capacitors are available in the market. These are the minimum maximum values which are mentioned. Okay, then ceramic capacitor. Ceramic capacitor uses the dielectric material as a ceramic. Okay, and there will be two metal plates, okay, like this, two metal terminals. Okay, it will be behaving as a capacitor. Okay, so the number which is written on that ceramic capacitor will decide its capacitance value. Another capacitor which is mica capacitor. Okay, mica capacitor will have the mica as a insulator material, or you can say dielectric material. There will be two metal plates like this. Okay, values they may be mentioned on that. Okay, capacitor. So these are the mica capacitor. Another type of category is there. I will not keep the figure over here because it was difficult to get the proper figure of the paper capacitor. So paper capacitor, they are using paper as an insulating material, or you can say dielectric material, and there will be two metal plates around that. So it is also one type of the capacitor, that is paper capacitor. So in laboratory you will find this and this capacitor, electrolyte and ceramic. Ceramic you need not to have polarity, but in electrolyte you need to see the polarity of the capacitor. Okay, so let's move to the next component. Okay, and which is you are right now studying in standard 12. Okay, those who are in standard 12, they are studying about the PN junction diode. Okay, so you have the PN junction diode looking like this in real time. Okay, and there will be number which will be written on this PN junction diode, and there will be one silver ring. What this silver ring will indicate? Silver ring will indicate it is cathode. Okay, it is having two terminal. One is called cathode and one is called anode. Okay, so I am marking over here on the symbol. This is the symbol of the PN junction diode. Okay, so over here, this side is anode, this side is cathode. A is for anode, K is for cathode. Okay, so this is shown cathode. So this side definitely will be anode, this side will be cathode. Okay, so PN junction diode is made up of P and N type of semiconductor. Okay, now how to make P and N type of semiconductor? In next session, Praveen sir will cover semiconductor material and how to make P and N type material. He will explain you. Right now also you may have studied in your physics. Very popular silicons and germaniums, they are semiconductor material onto which you add the impurity and you can make P and N type. If you combine them, you will have PN junction diode. So PN junction diode, it is used for unidirectional current flow. Okay, it is used in rectifier circuits, clipper circuits, clamper circuits, voltage multiplier. This circuit I will cover in my next session. Okay, rectifier, clipper, clamper, and if time permits, I will explain you voltage multiplier. Otherwise, we will skip voltage multiplier. But I am going to explain you about the diode circuit, where I will explain you how the rectifier works, what is the use of clipper, clamper, what is the use of rectifier. Okay, so where the basic element which is used as PN junction diode. Now, what is the speciality of the PN junction diode you are studying now? So it is operated in two regions. One is called forward bias, one is called reverse bias. In forward bias region, you will have very less resistance, around 40 to 50 ohm. So it will be treated as short circuit. Okay, it will be treated as short circuit. Simple connection between 2 points, that is treated as short circuit, SC, short circuit. And whenever it is in reverse bias, it will be treated as open circuit. I am writing OC over here. Okay, so that is the PN junction diode. In reverse bias, it behaves as an open circuit. In forward bias, it behaves as a short circuit. So it can be used as a switch also. Okay, so this is a symbol, this is the actual appearance. Now, after the PN junction diode, the researchers have made the spatial diodes. You may be familiar with this spatial diodes. Okay, this is very popular, everyone knows about this. That is called light emitting diode. In short, we say that it is LED. There are different colors of the LEDs available. Okay, that colors, how we can see different colors? Due to its materials which are used in the LED. Okay, so the color which comes from the its material. Okay, so different colors of LEDs are available. Okay, so that is depends on the which material is used. Where the LEDs will be used, LEDs will be used for indicator purpose, decoration purpose. Right now we are seeing the boards of the LEDs in the advertisement. In BRTS also you observe these LED boards. Okay, everywhere LED TVs are there, LED lights are there in our homes. Okay, so LEDs are very much popular. Now, what is the main reason why the LED has become popular? Because it consumes less power. Okay, you may have observed that in our homes previously there were CRT TVs, CRT monitors, but nowadays, I mean, after the CRT monitors, we have that you can say another category which are LCD. After the LCDs, nowadays we have the LED TVs. Okay, LED screens in our home because it consumes less power. Okay, now next, which is special purpose diode, which is Zener diode. I mean, the students which are in 12th, they are also studying this Zener diode. Okay, so Zener diode also has this ring which shows the cathode. Another side one is anode. Okay, Zener diode has this special application in electronics. It is used in voltage regulator. What is voltage regulator? Voltage regulator is used in, you can say, whenever you want to have constant DC. Okay, let's say if I'm designing my mobile charger of constant some volts. If it is of constant some volt, okay, and I need to have something which gives me, even though variation comes in the input or output, I should have constant 5 volt or whatever mobile charger voltage, let's say it's 3.2 volt. Then this component can make the voltage regulator. Okay, whenever you study in electronics in detail, Zener diode voltage regulator is used. Okay, if time permits, I will cover in my next session about the Zener diode voltage regulator. Okay, another category or another special diode which is varactor diode. Varactor diode symbol is this. Varactor diodes are the variable capacitance. It is also called varicap. Okay, whenever you want to have variable capacitor in the circuit, you can use this diode. You can operate in the reverse bias. In reverse bias, what happens? TRP sir, Praveen Prajapati sir will explain you in the lecture that in reverse bias, the junction will have the depletion region in between. As you increase the depletion region, as you increase the reverse voltage, depletion width will increase, and ultimately this behaves as a capacitor, and its capacitance will increase or decrease according to the reverse voltage which we are applying to this diode. So now varactor diode will behave as a variable capacitor. Where it will be used? It will be used in receivers. Let's say whenever we are tuning we are tuning no different receivers for the different stations. At that time there will be internal circuit that will be containing the varactor diode. Okay, so whenever we change that button, no, actually we are changing its reverse voltage and we are changing its capacitance. So our LC tank circuit's capacitance changes, so our resonant frequency changes, and we will be hearing the different stations. Okay, so that is about the you can say varactor diode. Let's move to the next portion, which is transistor. This also you are studying in standard 12. Okay, so transistors, they are made up of again semiconductor PN materials. Either it may be of PNP or NPN. There are two types you may be studying. PNP or NPN type transistors are available. Okay, so you will have the layers of NPN, PNP, and this 3 stands for 3 terminal. Okay, PNP, that means emitter will be of P type, base will be of N type, and P will be of collector type. If you are using NPN transistor, N will be of emitter will be of N, base will be of P, and again collector will be of N type material. Okay, the actual transistors, they are available in plastic cap, metal caps, like that. So this is a real picture of the transistor. BC547 is the number of the transistor. You can find the data sheet of that transistor with the use of this number. After the lecture, you can try it, Google it with this number. You will get the data sheet of that transistor. The data sheet will get you everything about the transistor, कि उसमें कितने टर्मिनल है, कितना मैक्सिमम वोल्टेज दे सकते हो, कितना मिनिमम करंट है इसका, कितना मैक्सिमम करंट है, कितना रेजिस्टेंस ऑफर करता है, वो सब चीजें डेटा शीट में अवेलेबल होती है. This is the symbol of the transistor. As you know that it has 3 terminal. Okay, you have to draw it like this. This arrow indicates whether it is NPN or PNP. Now arrow, whenever it is going outside, okay, it will be always from, like say, P side to N side. Arrow will be of always from P side to N side. So this transistor will be of NPN. If it is of PNP, then arrow will be going inside. Now where this transistor we will use? The transistors are used in amplifiers. What is amplifier? Amplifiers are used to amplify the input signal. इनपुट सिग्नल कोई भी लेट से साइन वेव मैं देता हूँ, कोई छोटा सा पिक टू पिक साइन वेव मैंने कोई फ्रीक्वेंसी का दिया, तो मेरे को इसको एम्पलीफाई करना है, यानी कि एम्पलीट्यूड में ही बढ़ाना है, उसका फ्रीक्वेंसी एज इट इज रहना चाहिए. सो इट्स फ्रीक्वेंसी शुड नॉट चेंज, बट इट्स एम्पलीट्यूड शुड बी मैग्निफाइड. ओके, इट्स शेप शुड नॉट चेंज. Without the distortion, it should get the output. Okay, so that is called amplifier. So in amplifier, the transistors are used. Another very good application of the transistor is transistor used as a switch. Okay, you know that switch has 2 configuration. One is on and one is off. Okay, there will be on between collector and emitter. Okay, and there will be off between collector and emitter depending on the input voltage applied on the base and emitter. Okay, you will study whenever you are studying electronics in detail, transistor as a switch. But in short, right now I would tell you that between collector and emitter there will be short circuit, so it will be on switch. Between collector and emitter there will be open circuit, so it will be off switch. Okay, so this is transistor's application. Okay, now next I will move to the next component, which is field effect transistor. Okay, it has this symbol. It is of 2 types, N channel and P channel. So this is a symbol of N channel, as you can see over here. This is a symbol of P channel, as you can see over here. Okay, now you can say field effect transistors are you can say the advanced version of the transistor. Transistors were difficult to fabricate on the chip. Nowadays everything is on the chip, and what is the requirement? Everyone wants that my mobile should be very small, my electronics gadget should be very small. So that was difficult to fabricate transistor on the chip. Also, it has some disadvantages which are overcome in the FET. FET offers very high input impedance. Okay, it is very easy to fabricate. FET is easy to fabricate on chip. Okay, so FETs are advanced version of the transistor, and it is providing the better functionality compared to the transistor. So same application of the transistor. It is used in amplifier. It is used as a switch. Okay, but with the better functionality. It is also made up of the semiconductor material. It is of 2 types, N channel and P channel. Okay, you will have N channel bar, and there you will have the P material in between, so that will form N channel JFET, and then you will have let's say if you want to make P channel FET, then you will have the P channel bar, and you have to add N channel material, and then you are forming a P channel FET. Another part of the FET is MOSFET. Okay, MOSFETs are nowadays used in the chip. because it has more advantage compared to the JFET. Okay, FET has two category. One is JFET, okay, and one is called MOSFET. Okay, we don't have to cover it in the detail, but just for your information, I am telling that in MOSFET there will be metal oxide layer which offers very high input impedance. Okay, so MOSFET has more advantage compared to the JFET. So nowadays we are using MOSFET in the fabrication. The terminals in the JFET, you will have source, drain and gate. Okay, you will have source, drain and gate. As the transistor has three terminal, JFET also has this three terminals: source, drain and gate. Okay, so same as transistor, but it is quite better compared to the transistor. So nowadays we are using MOSFETs in the chip. Okay, it occupies very less space. Okay, and easy to fabricate. So this is about the components which I need to cover. If you have any question, type in the chat box. I'm checking chat box now. If you have any problem, just type in the chat box. Otherwise, I will move for the components. Okay, I suppose everyone have understood. Okay, fine. So some questions are coming, which is input impedance. Okay, now what is input impedance? Now if you take any circuit, okay, whatever the resistance offered on the input side, that is called input impedance. And for amplifiers, input impedance should be high. Okay, so in short, right now you need to know about that only. That at input side, what is the resistance of it? That is called input impedance. Output side, what is the impedance of it? That is called output impedance. And for amplifier, input impedance should be high, output impedance should be low. Okay, so that is one thing which I need to clear. Okay, fine. Any other has not come, I think, no? Okay, so let's move to the electronics instruments which are used in laboratory. Okay, so we will see about power supply, function generators, CRO, DMM, and the breadboard. Okay, we will see about all this five one by one. Okay, what is power supply? That is DC supply which we are using in the laboratory. What is function generator? It is used to get, whenever you want to apply some AC input, we will use function generator. Whenever you want to observe any AC signal onto the screen, okay, that is CRO which is used. Advanced version of the CRO, that is called digital storage oscilloscope. That also I will cover. Then we will have digital multimeters, okay, which is DMM, okay, which is used to measure resistance, current, voltage, to test diode, to test transistors. And then we will have the breadboard. Okay, breadboard is used to mount the component on, it is used to mount the component to make the circuit temporarily. Okay, one by one we will see that. Okay, so first, power supply or the DC battery. Whenever you need any DC voltage to be applied in your circuit, let's say some of the circuits which need to be applied DC voltages, like if you are making simple circuit of resistors, transistors, you need to apply DC voltages. So from where you will take the DC voltage? So this is a kind of DC supply you will have. Okay, it's in, its back side will be connected with the AC. It will be connecting to AC, and lively it will be converting to the DC, and based on your requirement you can set it from these knobs, which voltage you want to set. Okay, these are the different terminals from where you will take DC. Each one is for different. Let's say one will be for fixed 5 volt, one will be for fixed 15 volt, and one will be variable. Whatever you want to set, you can set using this knob that will be available between that two terminal. Okay, now why we need DC supply? So whenever we are testing any circuit in laboratory, whenever we are performing experiment, we need some DC supply to be applied to the various electronic circuit. So this is very important, you can say, instrument in laboratory, which is DC battery. Okay, now next, function generator, which is used to get AC inputs. Okay, let's say आपको sine wave चाहिए, आपको square wave चाहिए, okay, आपको triangular wave चाहिए. क्यों चाहिए भाई? कोई सर्किट की रिक्वायरमेंट के उसको एसी इनपुट देना है. ओके, तो जब इलेक्ट्रॉनिक्स में हम यूज करते हैं तो लो वोल्टेजेस यूज करते हैं. तो ये जो फंक्शन जनरेटर्स होंगे वो लो वोल्टेज के होंगे, यानी कि 20 वोल्ट्स की लिमिट में वो एम्पलीट्यूड जनरेट करेंगे. कोई भी फ्रीक्वेंसी आप सेट कर सकते हो. ओके, एनी एम्पलीट्यूड बिटवीन 0 to 20 volt you can set. And another thing is you can choose these shapes which are available in the function generator: square wave, sine wave, or triangular wave. Okay, and you can apply the inputs, you can take the output from here and you can apply to the circuit. It will have two terminals. Okay, you can apply to your circuit which is connected on the breadboard, okay, or on the PCB. Okay, you can apply using this function generator. These are the various knobs to set the frequency, amplitude, okay, which shape of the signal you want to set. Okay, so this is function generator. Fine. Next is digital multimeter. Okay, you may have used in standard 12 that you are using resistance meter, or you can say ohm meter to measure the resistance. You are using voltmeter, you are using ammeter separately. Now everything is combined into this one, okay, which is called digital multimeter. As you can observe this, you can measure AC current, DC current, resistance. You can test continuity between 2 points. Now what is this continuity? Okay, what is continuity? Whenever you want to test whether the 2 points are connected or not exactly. Okay, let's say I have connected something in my circuit and that 2 points are connected or not, I can test it with the continuity tester. It offers a buzzer whenever the 2 points are connected. Okay, it blows a buzzer whenever the 2 points are connected. Okay, if they are not connected, the buzzer will not be there. Okay, so continuity test is very important whenever you are troubleshooting your circuit. What is troubleshooting? You are finding the fault in your circuit. Okay, whenever you want to test transistor or diode, this also used. Okay, you have to connect the diodes to terminal over here with the knob and you have to test the transistor or diode. There is a special procedure, but right now we don't have much time. Okay, so we can test the diode and transistor. You can find the YouTube video how to test diode and transistor using DML. Another important you will observe, that is CRO in the laboratory. It is used to observe the output waveform which you are getting from the circuit or from the function generator. So you will observe the sine wave like this onto the screen. Okay, after observing, what you can do is by use of the volt per division knob or time per division knob over here, you can measure the voltages and the frequency of the wave which is observed. Okay, but it has to be done manually. You have to done all this, or you have to do all these settings manually. Okay, so whenever you set it perfectly and you calculate it, you will get the frequency, amplitude. And if you have two signals, it has two channels, so you can apply another signal over here. So you will observe two signals simultaneously. एक साथ आप दो सिग्नल देख सकते हो. दो सिग्नल देख के आप उसका फेज डिफरेंस भी मेजर कर सकते हो. Okay, so CRO is used whenever you want to observe AC signals. Okay, so this is about the CRO. Okay, next. Okay, advanced version of the CRO is digital storage oscilloscope. Now in CRO manually you have to set everything, but in DSO there is one facility which is called auto. It will auto set everything. Okay, and it will display your waveform in very good manner. Okay, definitely all the functions of the CRO are available. Other than that, you have the mathematical operations you can do on the signal. You can find its frequency domain, that is called FFT, fast Fourier transform. And main important thing is you can store the waveform in pen drive or internal memory of this. Okay, that you will have the auto option. You will have the auto option. As I said, it will set your volt per division, time per division knob perfectly. Okay, so right now in laboratory you may observe DSO mainly. Okay, because it is the advanced version and it has very good facility. So we are using DSO in laboratories to observe the waveforms of your output circuits or the waveform which is coming from the function generator. Okay, another important instruments which we will use is breadboard. Okay, now this kind of holes will be available on the breadboard. It is like a bread. Bread में आप holes observe करते हो ना, वैसे इधर holes है. Okay, so it is used to mount the components. Component का जो lead होता है ना, वो ये hole में डालने का. Okay, it has two sections. I will say vertical section and horizontal section. This is horizontal section, and this one which I am right now marking is vertical section. So in vertical section, this 5 vertically will be connected. All these 5 will be vertically connected. जितनी भी आप column observe कर रहे हो, वो vertically 5-5 के group अंदर से connected है. Okay, अंदर से कनेक्ट का मतलब कि उतने वायर्स आपको कम लगाने पड़ेंगे. जैसे कि मैं एक रेजिस्टर का टर्मिनल इधर मैं डालता हूँ. ओके, तो दूसरा जो रेजिस्टर के टर्मिनल के साथ का जो कनेक्शन है वो ये चारों में से कहीं पे मैं भी डाल के उसके साथ कनेक्ट इंटरनली कर सकता हूं, क्योंकि ये 5 इंटरनली कनेक्टेड है. ओके, यू ऑब्जर्व दिस. दिस इज दिस इज हॉरिजॉन्टल सेक्शन. हॉरिजॉन्टल सेक्शन में 25 का ग्रुप कनेक्टेड होता है, यानी कि एक टर्मिनल मैंने इधर डाला कोई रजिस्टर का या डायोड का, तो दूसरे बाकी के जो बचे 24 उसमें से कहीं पे भी मैं दूसरा टर्मिनल किसी और का डालता हूं तो वो दोनों इंटरनली कनेक्ट हो जाएंगे. सो व्हेनेवर यू वांट टू माउंट द कंपोनेंट्स टेम्पररीली, ओके, यू कैन यूज दिस ब्रेडबोर्ड टू माउंट द सर्किट टेम्पररीली. मगर जैसे आपकी प्रोडक्ट बन जाती है फिर आप ब्रेडबोर्ड पे नहीं रख सकते, उसको स्पेशल पर्पस पीसीबी पे लेना पड़ता है. मगर जब टेस्ट करना होता है तो हम breadboard use करते हैं. Okay, so this is the breadboard where you will have the, you can say, holes which are connected internally, which is used to mount the circuits onto that. Okay, so this is all about the components. Now if you have any question, then type it in the chat box. I am referring the chat box now. Okay, varactor diode. So varactor diode I have not covered into the detail because it is right now not scope of this lecture. But varactor diode में मैंने जैसे बताया कि क्या होता है कि रिवर्स बायस में कोई भी डायोड होता है तो वो रिवर्स बायस में कैपेसिटर की तरह बिहेव करता है. तो जैसे आप रिवर्स बायस वोल्टेज बढ़ाते हो या कम करते हो उसका कैपेसिटेंस चेंज होगा. तो वो कैपेसिटेंस कैसे चेंज होगा, क्योंकि बीच में जो डेप्लेशन रीजन है आपका, ओके, डेप्लेशन रीजन है उसकी विड्थ बढ़ेगी या कम होगी तो उसके हिसाब से उसका कैपेसिटेंस चेंज होगा. अब डेप्लेशन रीजन जो होता है वो इंसुलेटर बिहेव करता है कैपेसिटेंस में, और जो चार्ज केजेस होंगे वो एज पे इकट्ठे होंगे. तो दैट विल, चार्ज कैरियर विल बिहेव एज अ मेटल प्लेट एंड इंसुलेटर, दैट इज डेप्लेशन रीजन, दैट विल बिहेव एज अ insulator. Okay, any other thing? What is tank circuit? Yeah, tank circuit is nothing but LC circuit, which you have studied in standard 11th or 12th. Okay, L और C को हम पैरेलल में डाल के कोई भी एक फ्रीक्वेंसी F is equals to resonant frequency F0 is equals to 1 upon under root 2 pi LC. So that is your formula of resonant frequency, that is called tank circuit, LC circuit, which is used as a oscillator. Oscillator क्या होता है, कोई भी एक frequency वो आपकी वो generate करता है. Okay, oscillation, that depends on the value of L and C. Okay, any other question, then you can type in the chat box. Don't raise your hand, kindly type into the chat box. If you have any question, type into the chat box. I hope this is very I mean helpful lectures to you to understand the basic components and the instruments. Dipanshu, if you have any question, you can type into the chat box. CRO does not have much spatial features. Okay, CRO is used to observe the waveforms. You can measure the frequency, you can measure the amplitude, and whenever you have two signals, you can measure the phase difference between them. Also, there are other facilities to test the components, but nowadays CROs are not much used. It is almost obsolete, you can say. DSO has the spatial features to store the waveforms, to do the mathematical operations like adding, subtracting, multiplexing two signals. You can convert waveform into the frequency domains in DSO. Okay, even other facilities are also available in the DSO. So you can find the YouTube videos. You can go and search DSO features. You will get explanation. Very good videos will be available, I think. CRO can test some of the component like transistor, not much. One, you can check CRO probe. Other components cannot be tested on CRO. Just you can observe the waveforms. use of the DMM, you can measure AC voltage, DC voltage, as PRP sir has said, okay, and to test continuity, to test diode, to test transistor. Some DMMs also allows to measure the capacitance, temperature, okay, resistance you can definitely measure using DMM, okay. Continuity means 2 points are connected or not. Do you have any other question? Do you have any other question, or we should end over here? Okay, so how was the session? How do you feel? If any suggestions, you can WhatsApp me. Okay, thank you. Give your feedback to me in WhatsApp. Okay, I am ending the meeting now.